Hello, good evening, friends. Welcome to Eastern Academy. We are discussing about electrical topics, and this is session 3, and this is part of embedded system programming. And today we're going to discuss about electrical circuits, series circuit and parallel circuit. Mostly, this is what we use it on your embedded system. Not more than don't get too much confused. So let us get into the board before we start discussing. Okay, so let us, the last session we discussed about a simple V or I. And we also discussed two formulas, V is equal to IR and P is equal to VI. Actually, these two are sufficient to master embedded systems. These two are sufficient, but you should know how to use them. That is what we discussed on that day, various mechanisms, such a way that I have a bulb of 230 watts at 230 volts, and I apply here 115 volts. Then we discuss what is the current. So please understand there are only three. You need to understand. One is voltage. One is resistance. Other one is current. The voltage is responsible to produce the current, but the current is the one which is giving you the power, I square R. That is most important. Actually, I square R is the one which is getting converted to P is equal to VA. And now we are going to do a small thing extra, that is, I connect, this is voltage. Now I connect two resistors in series. When I connect two resistors, the current flowing through here is common, because the electron starts from here, it moves up to here. That's why the I is common. So if you take, this is a resistor 1, this is resistor 2. The power produced by this guy is I square R1. The power produced by this guy is I square R2. Am I right? So do you understand? That is, we have a circuit, but I have now two resistors. They are connected in series. Since they are connected in series, this current is common, because the electron starts from here, flows through both and comes. So there's no way it has to be different. So if you connect a circuit, single circuit, the current is common. For example, you have a tank, and if the water comes through so many tubes, small tube, big tube, and so many tubes, and then there is a vessel. The beauty is this water flows here per second, per minute. It's common. It does not change. The flow is common. Understand? Same thing here. I have a resistance, R1 and R2. The values can be anything. One may be giving you less resistor, one may be more resistor, doesn't matter. For example, I have a big tube and I have a small tube, and the water goes here. The water could be less here. It could be more space being free, because it's a big tube. Whereas the water could be here fully occupied, because it's a smaller tube. But the flow of water will be same here. Now, let us do the same thing here. So this is clear now. So now I draw it here such a way that I can draw one more circuit there. You'll be understand. So I have a voltage source, and I have a resistors This is R1. This is R2. The power produced by this is I square R1. The power produced by this is I square R2. So the total power produced by the circuit is I square R1 plus I square R2. Am I right? I square R1 and I square R2. Now let us, for this voltage source, he will see the circuit as a one resistance, not multiple. So if you make this one as a single one, that is a equivalent. We call this as R. So the current is I. So the power is I square R. That means that if I make this as a single resistance, then that is R. And the power is I square R. Am I right? The power is I square R. And here I square R1 plus I square R2 because I have two resistance. That's what we discussed here. So I square R is equal to I square R1 plus I square R2 is equal to I square common and R1 plus R2. If you click both the side I square, R is equal to R1 plus R2. Understand? So if you connect two resistors in series, then you can add them together just like that. So the equivalent is, I just explained to you that why you are adding. So we know that most of us know that if I connect two resistors in series, we have to add them. We know that. Now I'm explaining that how we are adding them. It is because the power is produced by each one is I square R2. So that is the way we are producing. Please understand, after V is equal to IR, P is equal to VI, we have to remember R is equal to R1 plus R2 in series circuit. Please understand. These are all the very, very important things you have to remember. Not too much, only very little. The same way, there is one more way I connect. But please understand, for example, if I connect so many things, R1, R2, R3, R4, don't get confused. Do this, you get R3, 4. Then you add with that R2, 3, 4. Then add with this. Don't add all of them. Add 2 by 2. That's the way it does. You add only 2. Don't try to add more. You get confused. Same way, I have a battery, a power V. I connect a resistor here. This point. So the voltage at 5, whatever V, is coming here across this. So the current going through here is I is equal to V by R. Am I right? This is R. R1. Sorry, you take R1. So I1 is equal to V by R1. Let's take only R first. Now what happened? I have added one more resistance called R2. This is R1 we call. So I1 is equal to V by R1. And I2, the current going through this is I2 is equal to V by R2. So I have already told you that power is equal to simple. What? I square R. That's the right one. That's the correct one. But we also write this as a I into R is equal to I into V or V into I. That's the result we make. So that's why we have a formula called P is equal to VI. At the same time, we also write like this. I square is equal to V by R. I square is equal to V by R. So V by R into R. So V into V is V square by R. There are 3 formulas. All are same, but depends on we use it. Whereas in this case, I have V and I have a R. So the power is equal to the power dissipated by this resistance is equal to V square by R1. The power dissipated this guy is V square by R2. Understand? Now what happened? I connected them in parallel to the bulb, not in series. Okay, they are independent. Since I've connected independently these switches, this guy power is V square by R1. This guy power is V square by R2. So the total power produced by this guy is V square by R1. Yeah?
Sir, it should be V square by R2 now, sir, left side. Because...
Oh, sorry. V square by R2. Okay. V square by R2. Thanks. V square by R1 here. I put the connect things wrongly. Okay. The right side is V square by R1. Left side is V square by R2. So the total power dissipated by this circuit is V square by R1 plus V square by R2. Am I right? This is clear. I'm just going by power. Now, if I make this as a single battery and a single resistor, I make them as an equivalent of 1. That means that this is I. In that case, why I have to make equivalent? Because your Ohm's law is V is equal to IR. Your Ohm's law talks about one current, one resistor, one voltage source. That is, Ohm's law does not handle multiple voltage source. That's the problem. So we have to convert. If I have any number of resistors in the circuit, I have to make it as a single one. Then only you can apply Ohm's law. So this is R. So the power, this is V. The power produced by the circuit is V square by R is equal to V square by R1 plus V square by R2. Am I right? This is clear because I'm making an equivalent of that. So I'll draw it here because I don't have a space. Sorry. So the power is V square by R is equal to V square by R1 plus V square by R2 is equal to V square by R is equal to V. Take V square common. 1 by R1 plus 1 by R2. Tapa V square. So 1 by R is equal to 1 by R1 plus 1 by R2. So if you do this one, you will get R1 plus R2 by R1 R2, which is 1 by R. So R is equal to R1 R2 by R1 plus R2. That's it. So this is what the final one you have to remember. I just explained to you that why it came. So now let us summarize. Now this is very simple. You would have seen in colleges and schools, but I've explained to you now as a part of our program. I have to explain. That's why I've explained. So please understand, if I connect two resistors in series, R1 and R2, the equivalent R is equal to R1 plus R2. Same way, if you connect two resistors in parallel, R1 and R2 equal to R is equal to R1 R2 by R1 plus R2. Enough. You will do wonders with this. If you can able to do these two formulas, enough. That is, totally we have to remember V is equal to IR, P is equal to VI, and this two. Yeah, any doubt? Anything?
Sir, my doubt is that, sir, for series you are taking current common and for parallel you are taking voltage as common, sir.
Yeah, because we connect the voltage here common. See here, across the voltage I apply the components. Okay, the current will vary with each one of them because I'm applying a different. I'm applying same voltage to both the devices, but the current is different because I is equal to V by R. Since R1 and R2 are different. Yeah, but in the case of series, the current, once you start the current, it goes like this.
Okay.
But beauty is V1 and V2 will be different in series.
Different. Yes, sir.
Here
Yes,
I1,
got
I2
it.
will be different. Now let us solve some problems. Let us solve some problem. Then you will know that. This, if you could able to solve this problem, then you are great. I connect two resistors in series. One is 5 ohm. Another is 5 ohm. I apply here 10 volts. This is R1 and R2. This is V1 and V2. So what is V1? What is V2? You should be able to solve the problem in exactly maximum 2 seconds. So 5 plus 5 is 10 ohms series, 10 volt. The current is going to be 1 ampere. So the I is going to be 1 ampere. I is common. The I is going to be common 1 ampere. So V1 is equal to I into R1. 1 into 1 ampere to 5 ohm, 5 volt. And this is 5 volt. Am I right? Now, if you do the same thing like 2 ohm and 8 ohm, 8 plus 2 is 10. Same 1 ampere, but here is 2 volts. Here it is 8 volt. So understand this very clearly.
Sir, excuse me, sir.
Yeah.
Sir, can we conclude that if both the resistors, that is value of resistors is same, then voltage will also be same, no, sir? In the
Correct.
case of
Yeah.
series.
Yeah. Correct. Let's get divided. It get divided correctly, equally. This circuit is called voltage divider. This is the basics for electronics. If you don't understand this, then it's very difficult to understand electronics. Please, let me make a point very clear. This is the base. See, from electronic starts. Am I right? Actually, this voltage divider is the basics for starting electronics. That we are going to see that today as well as on the next year electronics classes. So please make sure that you understand this very thoroughly. If I start a thing like this, if I say that 10 volt, 1 ohm, what is the voltage here? What is the voltage here?
5, sir.
5, same, very simple, 5 volt. Now, I make this guy as 1000 ohm. What is the voltage here? What is it? 1000 ohm means what? What is the voltage here? First, this is what is R? R is equal to R1 plus R2. 1001. So 1001, 10 volt. This is what I. So into R is 1000. So if you do that, how much it is coming? 1001, 1000 by 1001, 10 into 1000 by 1001. This is almost 1. So you can say that it's approximately 10 volt. It is approximately 10 volt. Or you may call it as a 9.999 volt. If you make this one as 1000 ohm, 1 million ohm, 10 lakhs ohm, then what is the voltage? Then it is V not or V2. V2 is equal to 1 million divided by 1 million 1 into 10 volts. If you say that this is equal to approximately 10 volt or 9.999999 volt. There'll be more lines because 1 million by 1 million. So understand this. This has to be very clearly understood. Now let us make a point, one simple point here. If we keep on increasing the resistor here, the voltages keep on increasing. If we put here 1 ohm, then that is 5 volt. If we make it to 2 ohm, 1 plus 2 is 3. So it becomes 3.3 volt, 6.7 volt, or 3.333 volts, 6.666 volts. Now, if you make 1 volt and 3 ohm, 1 plus 3 is 4. 10 by 4 is 2.5. So this becomes 2.5 volt or V1. V2 becomes 7.5 volt. I make it to 4 ohm. 1 plus 4 is 5. So 10 by 5 is 2. So it becomes 2 volt. This becomes 8 volt. When I make it to 9 ohm, then this becomes 1 volt. This becomes 9 volt. When I make it to 99 ohm, then this becomes 0.1 volt. This becomes 9.9 volt. When I make it 999 ohm, then this becomes 1 volt, 0.01 volt. This becomes 9.99 volt. You understand that? When I keep on increasing the resistor here, the voltages keep on increasing. Now, let us assume that I make the resistance infinity. I make the resistor infinity, what will happen? It's too big. That time, when I make the resistor infinity, that means that, let us say, you are running. I put a resistor here. You will still run. Now, when you are running, I make a wall here, thick wall. Then you cannot proceed. That means that the wall is giving you what? Infinity resistance to the person who is running. The same way here, when I say this guy is infinity, that means that no current can flow. I become 0. That means that this guy is going to be open. Switch. A switch is on now. You understand? A switch is on. Sorry, off. Switch is off. When they make it switch is off, the voltage is how much? 10 volt. Do you agree that? Do you agree this? Because switch is off, I is equal to 0. When I is 0, I got 10 volt here. How come it is? This is V1. V1 is equal to I into R1. I is 0. 0 into 1 is equal to 0 volt. So this guy is 0 volt. This guy is 10 volt. 10 volt plus 0 is 10 volt. If you don't understand, let me know. This is the most important point you need to understand. This is the basics of your entire digital electronics. If you don't understand, let me know. I have a switch. If the switch is off, then I get here 10 volt across the switch. There's no common sense. I don't use any common sense. I don't assume anything. I put it using the actual equation. Let me know.
Excuse me, sir.
Tell me.
Sir, here resistance is infinity, right, for switch?
Correct.
So current will be 0, na, sir?
Correct, yeah.
So current will be 0. How it is 10 volts, sir?
Why not? 0 into infinity is 10 volt. Now we have a problem. Can you tell me what is 0 into infinity? What is 0 into infinity? Anybody? Somebody tell me the answer. What is 0 into infinity? It's a very simple maths. Am I right? What is 0 into infinity?
0, no, sir.
Yeah. The problem is like this. During schools, they taught you when you were in the 5th standard or 6th standard, they teach you 0 into anything is equal to 0. But very unfortunately, later they forgot to revise you. 0 into infinity is not equal to 0. You know that? 0 into anything is 0 except infinity. 0 into infinity is not 0. Please. Anybody? Because 1 by 0 is infinity. 2 by 0 is infinity. 10 by 0 is infinity. 100 by 0 is infinity. So 0 into infinity can be 1. 0 into undefined. Perfectly correct answer. I call undefined. That means that it could be 1 or 2 or 10 or 100 or minus 50. Anything it can be anything. So that is the reason here what we are doing. This is the voltage V. This is voltage V. So we say that V is equal to V1 plus V2. And this we don't know because this is anything. 0 into infinity is anything. You cannot say. That is a reason. Actually, they give a right word called indeterministic. This is called indeterminate. You cannot determine. That's why they call indeterministic. Or as somebody said, it's called undefined. As somebody said, undefined. Since this is undefined, you cannot find it. So this is, you cannot find it. So what we are using is using different method. For example, I'm telling you that I have given you some money. Let us say that I have a person. You are there. I given you some money. I given you some money. If I ask you how much I given you, you cannot tell me because I given you some money, which is undefined. You cannot say. But I tell you one thing. I have 100 rupees. I have 100 rupees. After I gave you some money, I have 30 rupees. Now you know that you are given 70 rupees. Am I right? Because I told you that I have 100 rupees in my packet. After I gave you some money, I have 30 rupees. That means that you will find subtract and do that. Same way here. This is voltage V. This is V1. This is V2. V1 plus V2 is equal to V. Okay. Now, this is not known to me. Undefined. Because 0 to infinity is undefined. But you know V1. What is V1? I into R1. I is 0 ampere. R is 1 ohm. So 0 into 1 is 0 volt. So this is 0 volt. V1 is 0 volt. Now what is V? 10 volt. V is 10 volt. So V2 is equal to 10 volt. That's the way we have got 10 volts. So please understand, most of you thinks when a switch is off, I should get 0 volt. No, you get 10 volt. You get 10 volt. That is one. Second thing is, if I have 1 ohm, the other one, I switch is on now. Switch is on. Switch is on. That means 0 ohm. Now, what is the voltage here? V2, V1. Now, whatever may be the I don't mind. Whatever may be the V2 is equal to I into R2. R2 is how much? 0 ohm. So,
0 voltage.
0 ohm is equal to 0 voltage. And this one is this is 10 volts. V1 plus V2 is equal to 10 volts. So this is equal to 10 volts. So understand that. This is 10 volts. This is 0 volt. Fine. So understand here. If I change a resistor to 1 ohm, then the voltage becomes 0.5, 5 volt, 5 volt. So if I change the resistor, I can change the resistor this from 0 ohm to infinity ohm. When 0 ohm means 0 volt, V2. R2. R2 is infinity ohm. This one is 10 volt. But when you change the voltage increases from 0 volt to 10 volt. Understand? If you increase the resistance, then the voltage keep on increasing up to 10 volt. So this is the three principles. You have to remember this. On means switch on, 0 volt. Switch off, 10 volt. And variable resistor, 0 volt to 10 volt. 0 volt, 10 volts. Okay, so have this concept, keep it. Don't forget this. This is very, very critical for our discussion. This is what we are going to take away to our electronics class. Before that, I want to explain you some more thing. If I draw a circuit like this, we draw like this, you normally get confused. You get confused. The moment you see the circuits, I explained to you yesterday itself, both cannot be. That is what I explained to you, that if both are on, it's a 0 ohm. So the current is going to be very high. The battery will burn. This is called short. You should never do that. You should never. Actually, I saw there is a call rating.
Sir.
It's called rating. Yeah.
Sir, sorry. I mean to say that if both are off, sir. Sorry, by mistakenly I typed on.
When?
If I connect 10 volts, if I keep open for both the resistors, open switch, off, I mean. Yes, sir, exactly.
Okay, this is what you wanted. Okay,
yes.
This one, the time we see this as the same voltage.
Okay.
And this voltage, you cannot determine. You cannot, because there is no source is connected here. So this is called undefined. This is also undefined because this point is not connected to this anywhere. So you cannot have a reference at all.
Both are undefined, sir.
Yeah, both are undefined.
Okay.
Both are undefined. So if you draw I'm giving an example. If you draw a circuit like this, don't get confused. These circuits are quite simple. You can always only two of them. You add these two. That is possible. So we can make this one as a simple. You can make this one as a simple. If they ask you what is the current I, make these two as a, you can make it 2 as a 1. 5 plus 1, 6. Now these two, I make them 6. These two can be added. 4 plus 4 is 8. Now, I cannot add this because this is parallel, this series. But these two are parallel, I can add it. 12 by 12 parallel, R1, R2 by R1 plus R2. That is 12 into 12. 12 into 12 divided by 12 plus 12. 12 into 12, 12 plus 12 is 24. So it's equal to 12 into 12 divided by 24. Add them to 6. You get 6 ohm. This is 6 and this is 2. If you make together these two now, it becomes 8. and 8 and 8 parallel. So 8 into 8 divided by 8 plus 8. 64 by 16 is equal to 4. So this becomes 4. These two are in series. 6 plus 4 is 10. Okay. That's it. 10 volt. The current is 1 ampere. The current is 1 ampere. That's correct. Yeah. The current is 1 ampere. Perfect. Understand now. So this is the way. Start solving the problem. Don't get confused when you have the connections like this. We have discussed so much. Now I ask you one question. I apply 230 volts.
Oh, okay. Arey, ఒక్క నిమిషం.
I have a bulb.
Oh, oh, भाई साहब, super, super. Super.
Okay. Now there's a bulb. And this is 115 watts at 230 volts. This is 115 watt at 230 volts. Now tell me what is the current? I is how much? These are the questions asked in your gate and exams and all. They're all very easy, but normally we don't give a attention to this. Can you tell me now? You can normally solve the problem in exactly in 10 seconds. I'm giving you 10 seconds. You see that? The moment you come to that level, then you are great. 10 seconds. Can you solve it? Please. Given a small circuit, I want the answer from you. What is I? Try to type an answer on your chat, please. You can make it on private, not on public. You can send me a private chat message. Not everyone, because I want at least 3 people to answer this. Somewhere I put a wattage, now people get confused. Somewhere when I put a wattage, people get confused. But convert everything into a resistor. Then you solve it. Convert everything to resistor. This is 230 ohm, 230 volts. So this is 230 ohm. This is 230 volt at 230 ohm. This is 230 ohm. This is 150 watt at 230 volts. You know, V square by P. That is V square is 230 volt divided by 115 watt. So 460 ohm. This is 460 ohm. Understand? Now, this is 460, this is 460. Okay, it become 920. Oh, I've given a mistake here. Sorry, I did a small mistake here. I wanted to do something different, but I didn't here. So that's such a, this is 115 watt at 230 volts. These are all 230 ohm volt watt at 230 volt. Easy to do that. That's why I wanted to change it. So this is 230 ohm. This is 230 ohm. This is 460 ohm. Now, if you see the circuit is confusing, but you add only these two. The 2 is the only which is series is there. But if you take this, 2 plus 1 is parallel, 1 is parallel is wrong. You cannot do that. You can do only 181. So one is this one. If you add 230 plus 230, this becomes now 460. Now 460 and 460 are in parallel. So that becomes of 230. Now 230 and 230 becomes in series. So that becomes now 460. We have 230 volt apply. So I is equal to 0.5 ampere. Okay, the power produced by the circuit is 230 volt into 0.5 ampere is equal to 115 watts. The total power. So understand that. So if I ask you this questions, you need to be able to answer that. Now I'll draw the same circuit. I ask you a different question. Let's see how you answer. What will be your answer? Now I apply 230 volts. Now I have a bulb. I have a bulb. This is 230 watts at 230 ohm. I ask you, what is a resistance across this bulb? Let us say bulb 1, bulb 2, bulb 3, bulb 4. What is the resistance across this bulb? That is V4. V4 is equal to how much? Can you tell me now? What is V4? See, I'm telling you repeatedly, these formulas are very simple. V is equal to IR, P is equal to VI, R is equal to R1 plus R2, R is equal to R1 R2 plus R1 plus R2. That's it. So let me know that what is V4. Now, normally the worst case time for this type of problems is 10 seconds. The worst case. Anybody? What? You're taking a very long time. That means you people have to practice a lot. This, watch these videos at home. Practice. I can, if when you are ready, let me know. I can share the test, theoretical test, which is there already. You can take the test. I will share the electrical test to you, but you have to make sure that you have understood this. Anybody give me answer for this? Taking time, very long time. I said 10 seconds, but taking very long time. Don't worry about whether your answer is right or wrong. Give an answer, enough. If you always want to give a right answer, you'll never learn how to give an answer. That's our problem. Our problem is that we always wanted to give a right answers. 46 volts. How did you get 46 volts? $230 volts. 230 volts. And now I'll explain to you how I am solving. So we have got 3 answers, all of them are wrong. 46, I've got 3 answers. 46, 230 and 230. I'll tell you how I solve the problem. Then you will know that. That is a method to solve the problem. Now, this one is there. Am I right? This is a resistor of 230 ohm. This is a resistor of 460 ohm. This is a resistor of 230 ohm. This is a resistor of 230 ohm. Because they are 230 watts and 230 volts. Now, if you know the voltage across this, then you can know this voltage. For that reason, let us take this as a point A. See, take point B. And this I take point C. This I take point D. Or this is D. This is C. Now we want the voltage between C and D. This is the voltage we want. This is B, same wire. This is also B. This is the same wire. That's also D. This wire means same voltage. Now I reduce this circuit now. This one is 230 plus 230 is how much? 460. So this becomes 460. $460 plus 460 in parallel. Then it becomes single resistor of. Now what happened? 230 volts is divided by 230 ohm plus 230 ohm. So the voltage across this is 115 volt. The voltage across this point. So VAB across A and B is 115 volts. And between B and D, this is 115 volts. Now we expand this. This is 460 ohm. This is 230 ohm and 230 ohm. Now these two are 230 ohms. This voltage 115 is divided by 2. So the voltage, this is C point. So the between this point, VCD is equal to 115 by 2, 57.5 volt. Get it? Do you get it now? Now how I solved it? You need to practice this. You need to, it does not come. It does not come overnight. It does not come over. This is a very simple formula. I don't use anything. Now I'm trying to prove you that very simple. We were not good at even a Ohm's law and power law. It's a very simple. I don't use anything. I told you beginning itself, I do not use complex theorem. I have not used even I never used the word called Kirchhoff law. No Kirchhoff law I never used. I never used Thevenin's theorem. I don't use anything at all. But it's all going to be very, very useful to you tomorrow when you discuss about electronics. So this is enough. What we discussed, this is enough. That is parallel circuit, series, and then V is equal to IR, P is equal to V. This is enough. If you don't understand this, how you got 57.5, let me know. The problem is we have learned a lot, but we don't remember or we have not practiced what we need. This is what we need. So you need to practice this thoroughly. If you don't practice this, yeah, these are there. I can share all these problems if you are getting into the thing. I'll share all the problems. These are there already in the app. If the moment you wanted it, let me send a message. I will share these questions to you. You need to be very perfect. That's why I challenge people that take the test 3 days, every day. If you take continuously 3 days, 10 out of 10, then you are good. The app, I have a test on the free test. The free test, you can take the test every day. They'll ask different questions. You take every day. Don't take two times a day. Take one in a day. And if you consecutively take 10 out of 10 in 3 days, then you're fine. It's not for me. It's only for you. Your self-assessment is for you. So this type of things require a lot of practice. But I'm not asking you anything great. I'm asking you to practice only. V is equal to IR. P is equal to VI. R is equal to R1 plus R2. R is equal to R1 R2 by. So I'll remember this. We have some problem of not perfecting small thing. Don't think that these are all small. Don't think that these are all small. They are the big actually. Most people fail in the interviews everywhere because of this. There's one of the students in my first batch. He said that attended my test, all these tests, only the series parallel. He could solve almost all the problem in the ISRO exam. You'll be very surprised. Same thing. If you solve all the problems, you'll be scoring very good marks even at GATE exams. That's a trick. We are studying something except fundamentals. When you are so weak in the fundamentals, you cannot rise to a building big. You know the rule, no? That is, when two people are constructing a building, two friends, person one, person two. This guy was trying to build a 3-floor house. This guy was trying to build a 10-story house. This guy is 3-story. Whereas this guy put a base of only small. He was only 3-story. This guy have to took a base of big for 10-story. So what happened? Before this guy completed his base work, before this guy completed the base work, this guy completed the 3 stories, and he was asking this guy, P2, hey, still you are in the putting the basement. But after some time, when he put 3rd floor, he could go up to 10 floors. But this guy could never rise single floor extra because his basement is weak. This basement is strong. So if you don't have a strong basement, then you cannot grow better. Everybody gets, you have a very, very temporary problem. You want to get a job. Tell me an easy method. No, that method will not get you the thing in the long run. You get the job, but you will struggle. You know that most people don't enjoy the job. Most people don't enjoy the job, whether it's IT or core, because you don't have this. But whoever I trained, even though during training they have not understand these things, after reaching the company, after a few years, they will tell me, sir, you have given me the right base. Now I could be able to grow the company, inside the company very fast. Wherever I go, it's in US or whether it's in India, multinational, wherever it is. Understand this nobody will give you so much of the tough concept in a very easy way. And please understand the industry. Industry wants you to understand very small thing in a perfect way. If you say you know it, you should know it. Don't say that just by saying knowing that. That's why I'm giving you this idea. So please make sure that I will, whoever wants that to take the test, but watch the videos. Make sure that you understand. Then ask me the test. I will share the test to you. Then start solving the problem. Then you will know how good you are. Okay. Now, we have some small doubts, lot of things. One is, what is ground? What is earth? What is negative voltage? Okay. We have lots of, sometimes we have a called no voltage. What is zero voltage? Understand? We have lots of the questions. So let's try to discuss all of them in the next session. So this all be very important when you are viewing the electronic circuits. These points are very, very important. So we have one problem generally. If something is very easy, so from school days I watch people, when something is very easy, we neglect them. We do not give importance to the simple things. We always try to give, somebody say AI, somebody say machine learning, we have to go to roll learn. But the problem is they all nothing. They all nothing. There was an article I studied. There was one guy called Embedded Guru. He's in US. He's too good. His name is Jack Gonzalez. He's a embedded guru. I was reading an article. He said, in my 40 years of embedded experience, nothing has changed. Whatever I studied in 40 years back, I'm applying today. That's the thing. When you're strong in fundamentals, whichever level you go, you'll be able to understand things very clearly. Don't think that we have so much of this one. What do you call it? Misunderstanding about Ohm's law. We say, oh, it's nothing, man. It's nothing. Am I right? It's not like that. It's not like that. You have to understand very clearly about Ohm's law, how to apply it. You'll be very surprised in the next classes, next not coming session, next day class, next week. When we start about electronics, you will be surprised that whatever we discuss now in the electrical, how exactly it is useful to you. Understand? Thanks a lot. I'll stop recording. Then we will have a session by after about 5 minutes.